Okay. Good morning, and welcome to lessons 2 to 4. And it seems like it's gonna be a lot, but it's really not a lot because it's one page per lesson. So let's dive right into this and let's get started. Um, so today, what we'll do is we're going to take a talk about lesson 2. Well, starting off with lesson 2. So a trigonometric identity. Identity is a trigonometric equation that is true for all permissible values of the variable in the expression on both sides of the equation. So it's basically it's a identity where it's whatever the left side is, it's gonna be always true on whatever's on the left side of the trig equations. So, and that's only for all possible permissible values. So, some of the stuff that we've already paid attention to or we've learned before are here. So, let's talk about that one. It says here, these are the reciprocal identities. So, something that we've already seen. So, sine theta is equal to the reciprocal of cosine theta. Okay, so you can write it like this, sine theta, and you can write it as 1 over cosecant, or we can say cosecant is the same thing as 1 over sine theta. Okay, now let's take a look at the cosine. So we can say cosine theta is equal to 1 over secant theta, or secant theta is equal to 1 over cos theta. And then tangent is the reciprocal of cotangent, so 1 over cotangent. Or we can say cotangent is the reciprocal of tan, or 1 over tan theta. And because tan theta is equals to sine over cos, or sine theta over cos theta, when we take a look at the cotangent, that's the reciprocal of tan. So when we take, if tan is sine theta over cosine theta, cotangent is a reciprocal of tan, which is reciprocal of this one, which is cos theta divided by sine theta. So these are the other trig reciprocal and quotient identities can be arranged and written in other forms. So when we see here, cosecant times sine theta, that's going to be equal to 1. Well, why is it equal to 1? So let's take a look at that one. Because when we say cosecant theta is we can rewrite that as 1 over sine theta. And if we multiply it by sine theta times sine theta and sine theta would cancel each other out and we're left with 1. So that's why that is equal to 1. Now we're probably thinking, okay, well, what's the point of all these? Right now we're doing the baby steps because when we get into proving trig identities, we might need some of these information. So this one here, secant theta. Well, what's secant theta? Secant theta is 1 over cos theta. And if we multiply that by cos theta, okay, and then the cos theta and the cos theta would cancel each other out, and then we're going to get an equal to 1. Okay, now cotangent is very interesting because we can say cotangent is cos theta over sine theta. And then if we multiply it by the tangent theta, and tangent theta is sine theta over cos theta, and we'll see that the sine thetas and sine theta will cancel in the numerator and in the denominator, and then the cos in the numerator and the cosine in the denominator will cancel each other out, which is equal to 1. Okay, so these are some of the basic trig identities that we've already seen, and we will continually see it as we move forward. So yeah, they talked about reciprocal identities. Okay, I just want to point that out. These are called the reciprocal identities because you just take the reciprocal of some of these um, trig functions. Now, the other one is called a Pythagorean identity. Pythagorean identity. Well, what is a Pythagorean identity? Now, let's bring us back to the unit circle. The unit circle is where recall that the point P on the terminal arm of an angle theta in a standard position has coordinates cos theta, sine theta, and the hypotenuse is 1 because its radius is 1. So this is actually bringing us back to chapter 6, part 1. So when we look at this one here, using the Pythagorean theorem, we know that this is 90 degrees right there. 90 degrees. So we know that x squared plus y squared is equals to the hypotenuse squared. Well, the hypotenuse is 1. So it's going to be 1 squared, which is equals to 1. So now let's put it in terms of cos theta. Okay, so cos squared theta, because remember x is a cos, x coordinate of that point, and y is the coordinate of that point right there. So if we write it as a trig, so it's cos squared theta plus sine squared theta is equals to 1. And that's what it's called Pythagorean identity because it applies the Pythagorean theorem. So now these are the 3 forms of Pythagorean identity. Okay, so here we can say cos squared plus sine squared equals to 1. But what we can do is we can sometimes rearrange this so that we can use it for our trig identity later on. Okay, so the stuff that we're doing now, we are going to see later on. So let's take a look. We can rearrange this cos squared theta plus sine squared theta equals to 1. So what are the other ways that we can rearrange this equation? So the other version of that, basically, we can isolate cos squared theta. So we can say cos squared theta is equals to 1 minus sine squared theta. So bringing the sine squared theta on the other side of the equation. So when we see cos squared theta, we can replace it by 1 sine squared theta. Or if we see 1 sine squared theta, we can replace it by cos squared theta. At this particular point, you probably don't know what I'm talking about yet, but we will see it down the road when we get to that part. Okay, so the other version of this is when we have the sine squared theta isolated. So we can say sine squared theta is equals to 1 minus cos squared theta. Okay, so just looking at the different versions after we did the arrangement. Now here, this one, cotangent squared theta plus 1 is equals to cosecant squared theta. Okay, well, how can we rearrange this one over here? Well, we can say that, what if I take this to the other side, the cos squared theta to the left side of the equation, and I bring the 1 to the right side of the equation? What would it look like? Cotangent squared theta minus cos squared, no, yeah, where's my cosecant squared theta? Cosecant squared theta, and that's gonna equal to -1. Okay, so cotangent squared theta minus cosecant squared theta equals to -1. I'll see if we could figure that out later. Okay, if I if we have time. And then what's the other version of that? What's the other version? So we can say, um, we can just have the cotangent squared theta by itself. We can say cotangent squared theta by itself. And if that's the case, it's going to be cosecant squared theta minus 1. Right, so if I bring this to the other side over there, it's going to be cotangent squared. So it's cosecant squared minus 1. Okay. Now I remember, I thought about another thing. Okay. Here's the other version. I didn't think about it right now earlier. So, but the other thing that we could do is I can take this cotangent squared and bring it over here. I can say cosecant squared theta minus cotangent squared theta, and that's equals to 1. Okay, so we can say these two, cosecant squared theta minus cotangent squared theta is equals to 1. Okay, now let's take a look at this one. What's the other versions or other ways that I can rewrite this, or we can rewrite this? So we can say that I can go tan squared theta. Okay, if I want to have the tan squared theta alone by itself on one side of the equation, and then I can bring this to the other side of the equation. So that becomes secant squared theta minus tan squared theta. Oh, sorry, minus 1 rather. Minus 1. Minus 1. So keeping the tan squared theta over here, and I'm bringing the 1 to the other side of the equation becomes minus 1. Okay, so that's one possibility. The other possibility is this one here, the secant by itself. Now, the other possibility is having the 1 by itself. So how can we have the 1 by itself? So if I take this to the other side of the equation and then leave that one right there. So I can go secant squared theta minus tan squared theta equals to 1. So if I take this to the other side, okay, it's going to be a negative tan squared theta, and then I have the 1 on one side. Okay, now if I can reverse these two, okay, I can reverse these two, and I can say, take this secant squared theta and bring it over there, and then the 1 goes over there. So basically taking this one, secant squared theta, on the left side and leaving the negative 1 there. So the other possibility is tan squared theta minus secant squared theta equals to negative 1. Okay, so there's like different ways or different varieties of writing this down on our for a trig identity. Okay, so this probably you're thinking, okay, what's the point of all these stuff? We will talk about that later. Okay, so let's see if we can prove something in here. Now, I know that we're not proving yet, we're just doing the basic identities, but I'll just talk about something like here, this one. Okay, let's talk about this one here. Why is that true? Why is that true? Let me see. Okay, so I'm gonna just prove that. I know we're not quite into it, but I just want to show it to you. Cotangent squared theta plus 1. Well, why is this equal to cosecant squared theta? Why? Why is that? Okay. So what can we do? Well, what do we know about cotangent squared theta? Okay, well, cotangent squared theta is the same thing as uh, cos squared theta over sine squared theta. Okay, so cotangent squared theta, we can rewrite this as cos squared theta. Okay, so that's from that one right there. I go plus 1. Okay, so what I'm gonna do is I'm gonna try to work this out and make it and show that it's equal to that. Okay, well, how can I add these two together? Well, we need to have the same denominator. Okay, well, same denominator, what can I do? Okay, well, the same denominator would be sine squared theta plus sine squared theta. Okay, that's the lowest common denominator. So I'm going to multiply this by sine squared theta. And then over here is another sine squared theta. Okay, so now we have the same denominator. Cos squared theta plus sine squared theta over sine squared theta. Okay, now it's all of that are the same denominator. If that's the same denominator, I can combine them. Okay, so I could do that. Here's what I could do. I could combine them under 1 sine squared theta. Okay, well, what's in the numerator? It's going to be cos squared theta plus sine squared theta. Okay, good. Remember, I'm just working out just one side of the equation, and to show that it at the end, I'm going to end up with this. Okay, so what do I know? Oh, I see. I recognize this. This is cos squared theta plus sine squared theta. Hey, that's the Pythagorean identity. Pythagorean identity. That's equal to 1. 1. 1 over sine squared theta. Okay, well, 1 over sine squared theta is the same thing as 1 over sine theta squared. Okay, so that's the same thing as 1 over sine theta all squared. That's the same thing. Well, what's 1 over sine theta? Well, 1 over sine theta is going to be 1 over, I can write it like this, sine theta all squared. And then 1 over sine theta, that's a reciprocal identity. Reciprocal identity. And 1 over sine theta is cosecant theta all squared. And what's cosecant theta all squared? That's the same thing as cosecant squared theta. So now, as you can see, that's why we've just proven that this is true. Okay, that is true. That's a Pythagorean trig identity. Okay, so we're going to have a lot more practice on that one, but just to show you that. Okay. The next lesson, oh, I know it's just, that's one lesson on its own. The next lesson is verifying. Okay, well, what does it mean by verifying? We're also going to need this later on when we do the trig identity, proving trig identity. It is to check our solution if our solution is correct. So verifying means to check. Okay, to check our answer. Okay. Okay, so to verify means to show that an equation is true for a specific value of the variable. It does not prove the equation is true for all values, but it does prove that the equation, and it does not prove that the equation is an identity. So we can just verify, just to check that it is true. So here, example number 1, verify that the equation cot squared theta plus 1 is equal to cosecant squared theta is true when theta is pi over 6. Okay, so let's see if we could figure this out. Well, where is pi over 6? Okay, now it's kind of taking us back to chapter 6. Okay, it's taking us back to chapter 6. Where is pi over 6? So pi over 6 is right here. Now from here to here is pi, right? From here to there is pi. So we got 6 equal parts. So this is pi over 6 right there. So that's pi over 6. And what does pi over 6? What are the coordinates for pi over 6? That one would be root 3 over 2 comma 1 half. Okay, so these are something that you are probably very familiar with, and these are the exact values for that pi by 6. Right there. So what can we do? This is the cos theta, and this is the sine theta. Okay, so the x is the cos theta, and then the y is the sine theta. So we're going to do the left side, and then this is the right side. So the left side is cotangent squared theta plus 1. Okay, well, what's cotangent squared theta? Cotangent squared theta, cotangent squared of, well, what's theta? Theta is pi by 6 plus 1. Okay, so it's asking, well, what's a cotangent squared of pi by 6? Cotangent is cosine divided by sine. So if we divide these two together, the denominators cancel each other out, then we're left with root of 3. So that's going to be root of 3. And then what are we doing with the root of 3? We're going to square it. Square plus 1. Okay. Well, what is this? Root of 3 squared plus 1. Well, root of 3 squared plus 1 is equal to 4. 4. So the left side, when the angle is pi by 6, the value of this is 4. 4. Okay. Now, what about the right side? What about the right side? Right side is cosecant squared theta. Okay. So what does that mean? It means cosecant squared of pi by 6. Okay, well, what's cosecant of pi by 6? Cosecant is the reciprocal of sine, right? So if the sine is 1 half, the cosecant is the reciprocal of sine. So it's going to be 2. 2 squared. And what's 2 squared equal to? 2 squared is equals to 4. So we said the left side is equals to the right side. So that's how we would verify our answer. Okay, so it's correct. Okay, that's example 1. Now let's take a look at example number 2. Example number 2. Verify, so that means like to check that the left side is equal to the right side, and then it is true when x is equals to 3 pi by 4. Oh, okay, I see. I think this is supposed to be theta. Okay, let's fix that here for a second. This is going to be theta because this is theta and theta. Okay, let's fix that. So let's visualize where 3 pi by 4 is. Where's 3 pi by 4? Okay, it's taking us back to our unit circle. 3 pi by 4. So from here to here is pi. So 3/4 of a pi. So 1, 2, 3. So that's this one right there. Okay, I'm just gonna, because this is 3 pi by 4, I'm gonna write down the coordinate of this. So this is gonna be negative root 2 of 2, or negative root 2 over 2, comma, positive root 2 over 2. So negative root 2 over 2, positive root 2 over 2. And this one here is one of the special angles. So we know the exact values for those things. Okay, so what does that mean? Let's see. Let's verify the left side and the right side. Left side and the right side. Okay, what does the left side look like? Left side looks like this. Tan squared theta plus 1. So that's my left side. And I'm going to try to verify if it's equal to the secant squared theta. Okay, for theta being 3 pi by 4. So tan squared of 3 pi by 4 plus 1. Okay, well, what's tan squared of 3 pi by 4? The very first thing we're going to do is look for what's tan of 3 pi by 4. Tan of 3 pi by 4. Tan is sine divided by cos. So sine divided by cos is going to be negative 1. So negative 1, and then here tan squared, so it's negative 1 squared plus 1. Okay, let's figure that out. Negative 1 squared is 1 plus 1 is 2. So the left side, the value is 2 when theta is 3 pi by 4. What about the right side? What about right side? Well, what is secant squared theta? So that's a secant squared of 3 pi by 4. Okay, so where's 3 pi by 4? It's right here. Which one is secant? Secant is the reciprocal of sine. So this is cos theta, and then this is the sine theta. Secant, the reciprocal of cosine. So secant squared is the reciprocal of cosine. So we're going to take the reciprocal of these two and then square it. So reciprocal of that would be negative 2 over root of 2 squared. Okay. Now, if we square all of that, that's going to give us, the negative will be negative times negative will give us a positive. 2 squared is going to be 4. And then square root of 2 squared is going to be 2. So 4 divided by 2 is 2. So these two are equal to each other. So that means the left side is equal to the right side. Okay? So that's how we would verify. And now we're on the last one. We're going to verify the equation. All of these mass is really equal to sine of x. Okay? So let's give it a try. And we're going to see this. Is this true for 30 degrees? And is it true for pi by 4? Let's see. So what we're going to do is we're going to do the left side. And then right side. Okay. Where is secant, so secant 30 over tangent of 30 plus cotangent of 30, okay, is equals to really sine of 30. What can we do? Okay, now this is going to be a longer one. Let's visualize where 30 degrees is first, okay, because we're going to need it. So here's again a unit circle, which are very familiar with. 30 degrees is right over here. So 30 degrees. So 30 degrees is going to be root 3 over 2, comma 1/2. So this is going to be the cosine of 30. And then the 1/2 is the sine of 30. Got really tiny. So root 3 over 2. Root 3 over 2 is a cosine of 30. And then 1/2 is a sine of 30. So that's this point right there. Okay, so what can we do here? Back to this one. Secant of 30. Well, what is secant of 30? Secant of 30 is the reciprocal of cosine. Reciprocal of cosine. So that's going to give me 2 over root of 3. Okay, now divided by, what's tan of 30? Tan of 30 is sine of 30 divided by the cos of 30. So that's going to be 1/2 divided by root 3 over 2. So 1/2 divided by root 3 over 2. Then this, the 2's would cancel. Then we're left with 1 over root of 3. 1 over the root of 3 plus, what's a cotangent of 30? What's a cotangent of 30? Cotangent of 30 is cos divided by sine. So cos divided by sine, that's going to be root 3 over 1. Okay. So how can we simplify this mess? How do we do that? Well, what we can do is we need to, this is a complex fraction, meaning we have a fraction in the numerator and some fraction in the denominator. We're going to do some work in here. We need to have the same denominator. So this is going to be, I'm going to multiply by root 3 over root of 3 here, so that the denominator here are going to be the same. So I have 2 over root of 3 over 1 over root of 3 plus 3 over root of 3. Okay, so this is going to be 1 over root of 3 plus, okay, this one here, root of 3 times root of 3 is 3. 3 over root of 3. So that's going to be 4 over root of 3. And then if we divide those two, the root of 3's would cancel, and then you get 2 divided by 4, which is 1/2. 1/2. Well, let's take a look at that one. Well, what's sine of 30? Sine of 30 is 1/2. So 1/2 side, and on the right side is 1/2. So the left side is equal to the right side. Now we're going to try that for pi by 4. Okay, now for pi by 4. Well, where is pi by 4? Pi by 4 looks like this. This is pi by 4. So what's a pi by 4? What are the coordinates there? That's going to be root 2 over 2, comma root 2 over 2. And this is going to be the cosine of pi by 4. And then this is the sine of pi by 4. Okay, so we are familiar with this one in chapter 6. So let's try that. We're going to verify it. Left side and right side. So what does the left side look like? Left side is secant of pi by 4 over tan of pi by 4 plus cotangent of pi by 4. Okay, let's see. Okay, well, what's secant of pi by 4? So secant of pi by 4, secant is the reciprocal of cosine. So the cosine is root 2 over 2. So the reciprocal of that would be 2 over root of 2. Okay. Divided by, what's tan of pi by 4? Tan is sine of pi by 4 divided by the cosine. So sine is root 2 over 2 divided by root 2 over 2, which is 1. Plus cotangent of pi by 4. Cotangent is cos theta divided by sine theta. So cos of pi by 4 is root 2 over 2 divided by root 2 over 2, which is 1. Okay, so that will give us 2 root of 2 divided by 2. So 2 root of 2 divided by 2. Okay, how do we do that? It's going to be 2 root of 2, 2 root 2 times 1/2, which is 1 over root of 2. Now, because 1 over root of 2 is something that we are not familiar, well, we are familiar with, this is the same thing as root 2 over 2. Now, on the right side is sine of pi by 4, and the sine of pi by 4 is root 2 over 2. So the left side is equal to the right side. Okay, so that thing about this one here is verifying means to check that it is true for the given information. Okay, so the next thing that we're going to do is lesson 4. We're really speeding the things up in here, and like I said, it looks like it's a lot, but they are really, really highly connected to each other. So we are going to be, it's better to just do it all at once. So in terms of lesson 4, we're going to talk about simplifying trigonometric expressions. So how can we simplify things? Okay, because later on we're going to talk about trig identity. We're going to try to always simplify things to show that the left side is equal to the right side. So what we're going to do is determine the non-permissible values of each expression. Okay, well, first one is to do the non-permissible value. Okay, well, what's a non-permissible value for this one in here? What's a non-permissible value? Well, the non-permissible value is if the denominator is 0. Okay, so the non-permissible value. So just like when we talk about a rational expression, rational equation, we looked at the non-permissible value, which is where the denominator is 0. So we're looking at this one. What are the values that will make the cosine x 0? So what values of x that will make the whole cosine of x, cos of x, equal to 0? Okay, and that's what we're trying to figure out. So where is cosine 0? Okay, let's always have a visual here because bring it back to what we already know. Okay, so here's a unit circle. Where is cosine 0? So cosine is 0. Remember, cosine are the x values on our unit circle. It's 0 here, and it's 0 there. Okay, so well, what are those angles right there? So x is equals to pi halves, 3 pi halves. So this is pi halves. This is 3 pi halves, 5 pi halves, and so on. So it's going to be, okay, it's going to be it's really every multiples of odd multiples of pi halves, really, right? So that becomes, so if we want a general solution, it's going to be x is equals to pi halves. So this is from here to here, that's pi halves. And then to get to the next one is another pi, so pi times k, where k is an element of integer. Okay, so every time we get cosine of the angle is 0, that's where it's undefined. Okay. Now what about this one? What will make this tangent 0? Where is tangent 0? Tangent is 0. We want tan of x cannot equal to 0, right? That's our non-permissible value. Well, where is tangent not equal to 0? Well, what is tangent? Tangent is when it's sine of x equals cos of x. So again, in this particular case, we don't want the cosine of x being 0, and also we don't want the numerator to be always 0, because if the numerator is 0, it will also be undefined. So we don't want the cos of x to be 0, and we also don't want the sine of x equals to 0, because that will make undefined denominator. So this is where both sine of x is equals to 0, where the sine of x 0, that's going to be at 0 pi 2 pi, and so on. Okay, and we also said that we don't want the cosine to be also 0, so cosine of x cannot equal to 0, and that one would be pi halves, 3 pi halves, 5 pi halves, and so on. Okay, so there are many possible places where there are non-permissible values. Okay, so now let's take a look at this last one in example 1. we're looking at the non-permissible value. What is a non-permissible value? So in the non-permissible value, we look at the denominator. Okay, so the denominator is 1 plus sine of x, okay, is 0. So what values of x will make that 0? Well, let's see here. So sine of x equals to negative 1. Well, where is sine of x negative 1? Sine of x is negative 1 over here at 3 pi halves. So x is equals to 3 pi halves, okay? And every multiples of 3 pi halves. So the general solution would be 3 pi halves plus 2 pi k, where k is an element of the integer. Okay. So looking at the non-permissible value. Now, the other thing in this particular case is we're going to look for where there is a denominator. So remember, the denominator of any fraction cannot equal to 0. So this part here, that's a denominator. But cotangent also has a denominator. Cotangent also has, remember, cotangent is cosine x over sine of x. So we have to look for where is sine of x also, because that's becoming a denominator too. Where is the sine of x? 0. So sine of x is 0 here at 0 and on pi. So in this particular case, sine of x equals to 0. So that x is equals to 0, pi, 2 pi, and so on. Okay, so all of these angles will result a non-permissible value. So in this particular case, always look for fraction and its denominator. Okay, because every time there's a denominator of 0, it will become undefined, and that will be a non-permissible value. Okay, so that's that part. Let's take a look at example number 2. This is where we're gonna first write down the expression as a single trigonometric function. Okay, so let's just do that one. What's a cotangent of x times sine of x? Okay, well, can we simplify it? Simplify. And then they said it single trigonometric function. Well, how can we write this as a single trig? Let's see if we can. Well, what's cotangent? Well, cotangent, we can write it as cosine of x divided by sine of x. Okay, so we can say cotangent of x is equal to cos of x divided by sine of x and times sine of x. So if that's the case, sine of x and sine of x cancel each other out. So now we are just down to a single trig function, and it's going to be just cosine. Okay, so that's nice. We've simplified all of that to just cosine. Let's take a look at letter B. how can we write this and simplify this as a single trigonometric function? So cosine of x divided by cotangent of x. Okay, well, what does that mean? Cosine of x divided by, okay, what's cotangent? Cotangent is cos of x divided by the sine of x. Okay, so now we are creating a complex fraction. So what can we do? We can say we're going to divide, and to do that, it's the same thing as multiplying the reciprocal. So cosine of x times the reciprocal of this, so sine of x divided by the cos of x, and you'll see cos of x and cos of x cancel each other out. Now we are down to just sine of x. Okay, so we've cleaned all of these up. We've simplified it to just sine of x. And these ones are baby steps because we're going to see it quite a bit in our solving, proving trig identity, which is pretty fun. Okay, let's take a look at letter C. Secant of x. Okay, well, what is secant of x? What can we do? Secant of x is reciprocal 1 over cos of x. Okay, that's what it is. And then we're supposed to multiply by cotangent of x. Okay, well, what's cotangent of x? Cotangent of x is cos of x divided by sine of x. Sine of x. Okay, and then sine squared of x. We'll just leave it like that. Is there anything that we can cancel? We can cancel cos of x, that one. And then we can also cancel one factor of sine of x. Okay, this sine of x will cancel one of the sine of x in the top. So it's just going to be 1. So that becomes sine of x. Okay, so all of that is just, all of these is just sine of x. Okay, we'll do 2 more. 2 more. Okay, oh, 3 more, sorry, 3 more. Cotangent of x times tan of x divided by cosecant of x. Okay, this is going to be interesting. So let's see here. Cotangent of x times tan of x. Well, that is going to be 1. 1. Okay, so cotangent of x times sine of x, because they're reciprocal of each other, that's just equal to 1. Okay, now if you don't want to do that, like let's say you've forgotten that's 1, let's see here. Cotangent of x is cos x over sine x times sine x over cos x divided by, okay, what's cosecant? It's going to be 1 over sine of x. Oops. So cos of x divided by the cos of x, they cancel each other out. Sine of x divided by sine of x, they cancel each other out. So we're going to have just 1 in the numerator divided by 1 divided by sine of x. So that becomes just, I'll do it this way, 1 over sine of x, and it's 1 divided by 1 sine of x is going to be sine of x. Okay, so all of that really just boils down to sine of x. And then letter E. What does this all of these mess cleans up to? Let's see. Secant squared of x, that's the same thing as 1 over, because remember secant, we have to remember secant is the reciprocal of cos. So that's going to be 1 over cos squared of x times cos of x divided by cosecant of x. Well, what's cosecant of x? Cosecant is 1 over sine of x. And it looks like we're going to have some kind of a complex fraction in here. I'm just going to go to the side in here because we're running out of room. Now there's a cos of x. We'll cancel one of the factor of the cos of x, so that's just becomes 1. So now I really have 1 over cos of x divided by 1 over sine of x. And how can I do this one here? 1 over cos of x is 1 over cos of x. And if I have to divide by this one, it's the same thing as multiplying the reciprocal. So that's the same thing as sine of x over 1. And then here, sine of x divided by the cos of x, which is equal to tan of x. So that's our single trig expression. Okay. Now let's do letter F. This is our final one. Cosecant of x times cotangent of x times secant of x times sine of x. Okay, so it's quite a lot of stuff, but is there a way to clean this up? Is there a way to simplify this stuff? Let's see here. Cosecant of x is the same thing as the reciprocal of 1 over sine of x. Okay, that's the first one. What about cotangent of x? Okay, cotangent of x, we can write it as cos of x divided by the sine of x. Okay, times secant of x. Well, how can I write secant of x? Another way of writing secant of x is going to be the reciprocal of cosine, so 1 over cos of x. And then lastly, times sine of x over 1. Okay, let's see if some stuff are going to cancel out. I can see that this cosine of x and the cosine of x here are can be simplified, right? Or canceled out. This sine of x in the numerator will cancel the sine of x in the denominator. So that cancels out. So if that's the case, we're left with 1 over cosecant of x. 1 over sine of x, which is equal to cosecant of x. Okay, so that's, after all of that, it really boils down to cosecant of x. Okay, I think what I'm going to do is I'm going to stop right there because it's already a bit of stuff that we've talked about in this particular video. So just kind of refresh your memory again. So we talked about reciprocal trig identities. Okay, so we're already familiar with this one because we've already talked about this in chapter 6. So that's a good one. And then we talked about the Pythagorean trig identities. We are probably not going to do this one right now. This is a good introduction. We will use this information when we do the trig identities. And then we talked about verifying. That's a way um, to check, okay, that the left side of the equation will balance the right side of the equation. Okay, so you've got some examples of that. And then we have simplifying trig expressions. Again, this is like a groundwork. This is the baby steps for basically the next topic, which is proving trig identities. Okay, so in this particular case, the practice questions, these are the ones that we could do. It's not a lot. It's not absolutely not a lot. Now I wrote it down. It's page 611, I believe. Okay, so for our practice, we could do page 611 to 613. And then we're just going to try question number 3, 4, and 5. Okay, so those are the only ones that we're going to do for today. So questions, please try questions 3, 4, and 5. So question 3 talks about writing as a single term, a single trigonometric function. Question 4 is non-permissible value, looking at the non-permissible value. And then question number 5, that would be the verifying. So pretty much the ones that we've done in lessons 2, 3, and 4. Okay. So I want to take this opportunity to thank you for watching the video. We are getting closer and closer to the end of our course. So keep up with the work, the good work that you do. And if you have any questions, you can send me an email. And if if it's easier for you to ask the questions instead of typing it out, and if you're not sure how to ask the question even, what you could do is you can send me an email, and then we can plan on finding a great time to do a Google Meet. Okay, so try to reach out. It could be from these questions, it could be from the other questions. Okay, it doesn't matter. So if you have questions that that you wanted to ask me, you can either email me the question, or you can we can set up a Google Meet time, and then we can actually meet together. So there you go. It's 12:07, so I'm going to leave you with all these questions, some questions, and thank you very much, and I wish you a very good day today. Okay. Have a great day today, and I'll talk to you soon. Okay. Thank you for watching. Goodbye for now.